Hello, everyone. So I am back, and if you have been one of those people who gave me all that positive feedback, I really appreciate that. It really helped me get back on my feet. And okay, so since we all know we hate videos which take forever to start, so what video is going to teach you is hopefully a lot about how to use Raycast because what happened is a student of mine asked me for help regarding a mechanic. He wanted to make a Spider-Man style rope thing where like you aim and fire and then that you get pulled towards that point. There are quite a few interesting problems you could say that do arise during that, mostly because of certain things a lot of people do not know about Raycast and hit info, etc. So we're gonna go through all that, and we're gonna make that mechanic. And as you all know, my style is to prefer reusability of code. So what we're gonna do is make a kind of a script that is a component which you can reuse for that mechanic. So whenever and if ever you ever need some kind of rope shooting towards a point and then getting pulled or something like that, you should be able to reuse that component. Okay, so what we're gonna that is a mechanic. I hope you have seen my other videos so you know the difference between mechanics, dynamics, and aesthetics. For that, I recommend the first video I made about planning your game. So let's create a script. This will be our reusable component slash mechanic. So we're gonna call it, let's say, Raycast mm, pull mechanic. Okay, we don't want to call it Spider-Man web mechanic because that would be a bit too specific. And let's open it up. Reload all. And before we do that, let's set up our scene a little bit so we can easily test it. And that was an accidental flick. Let's create a 3D plane. Let's create a 3D cube. That will be our player. And let's create another cube. Okay, so let's go to the plane. Let's make that plane a bit wide. Let's rename this to our cube boy. And let's make this cube to be where we want to shoot our rope towards. Okay, that does not mean that our code would require a target. It would, you can basically use that mechanic to fire where you're looking, etc. But for now, I don't want to create a whole city for you to Spider-Man around. So we're gonna have this cube. So in a way, we'll know that if we are hanging on a point on that cube and it's working all correctly, etc., we'll be able to test it by moving this cube around and know that our mechanic is actually performing like we intended it to. Okay, so this is the cube boy. So basically, our reusable mechanic goes on him. Correct. So whenever in the future anyone wants a player to be able to do this, uh, they should attach this component on their player. The reason to do it this way is because we do not want to pollute their main script. Their main script would have other things, and they could refer to this component whenever they want to fire and whenever they want to detach, etc. The whole control mechanism of when to do it and stuff like that would be in another script, the main one, preferably, or the control script, etc. So uh, we open it, and this is our Raycast pull mechanic. Let's remove this to get us a clean start. And for some reason, it took more time than it should have. Okay, so first of all, since this is a reusable script, we need to do some smart thinking. First of all, we know that for that our functionality to work, we are definitely going to need a rigid body on our own object. So this this line will ensure that a rigid body is attached on that player or whatever we attach our script to. This is just like foresight. Most probably, the player will have already have a rigid body on it, but we just want to make sure that our script does not throw errors, and will also let anyone who opens this script to know that you know either have a rigid body properly configured or I'm going to add one, so I do work either way. Now, next thing we're going to do is okay, so another important aspect we need to ensure is that this script should not rely on the control script. Okay, so in other words, we cannot ask for things like the you know when to fire or stuff like we this script is supposed to be really light, and it's just going to wait there, and it needs to be told when to fire the rope. So what we're going to do is, first of all, we're going to ask for some, well, let's make it simple. A public method would be needed, which would be fire. Fire is a kind of a to attach. Yes, this would make more sense. Attach rope to target, or no, let's say fire rope towards target. Okay, so this is a functionality, a method our mechanic is providing. This is in fact the main mechanic. It allows you to fire ropes towards a target. So what other things we're going to need? We're going to need vector 3 where to fire from, origin. Let's say origin, comma, vector 3. Okay, vector 3 direction. Okay, so direction. Okay, so another interesting thing I can explain right here is that this vector 3 is a position. This vector 3 is a direction. There's a difference between both of those things, which I will cover in a second. Okay, he says, variable names and private must start with a lowercase. Yes, they should. Okay. Now, okay, there's something else. I am kind of rusty. I've been method name with an uppercase letter. Yeah. Okay, we'll figure it out. Now, this method needs these two things. So whoever is going to be using this mechanic will be giving us these two things. What we need now is some basic stuff, which is the the range. Okay, so float range. So how far you want to be able to. This should be public because we want to give them the ability to change this. So maybe their range depends on uh, things like power ups and stuff. So let's say 100 is the default value. I want to give a default value here because our script should work without a lot of nagging. Okay, so next step is we want to fire towards that direction from origin. So first of all, we want to create a ray. Okay, so right now, this ray variable, the ray, we, let me make it a little bit more uh, explanative. Ray we will be shooting. Okay, so all the information we kind of need for this has been given to us. Okay, so new ray, C is asked for origin and direction. So we already have those. We have been given those. Origin, comma, direction. Oh, no, direction. And see, this V needs to be small. Oh, okay. Now, we have a ray, and now we need to shoot that ray and first of all see if we even hit anything. Okay, so what we're going to do is physics dot ray cast. Now see, the first of all it's asking us for a ray, which we have, we'll be shooting. So basically this is how it got um, both origin and direction from us. Now we need maximum distance, we have range. Okay, then we need to ask for a layer mask and query trigger interaction. So basically it's saying, do you want me to hit triggers or not? So these two things I think we should give the, whoever wants to use our mechanic the ability to uh, give us. Okay, so layer mask, and let's make it more explanative. Layers, okay, layer of objects the row can attach to. Okay, that's a lot of explanation for whoever wants to use our script. Hopefully they never have to open our script. That's the idea. So public, and next we need to query trigger interaction, and we need to ask them about this. Okay, so we can say, do you want to attach to triggers? Okay, now let's use that information. Layers of objects the row can attach to, and do you want to attach to triggers? Okay, so now we fire this ray. Okay, this ray, if we put our cursor here, this method wants to return a bool. So in other words, physics.raycast does not, I repeat, does not give you any information about what it hit, and this basically, this overload of this method does not give us information about where it hit, what it hit, etc. It just tells us if it hit something. Okay, so this gives us a nice idea. We put that inside an if, and basically this is our way of saying, if you fire this ray, would you be hitting something? Okay, so now we're inside an if else statement. Okay, so we'll get here if we do hit something based on all these parameters. Okay, so now we need to fire another ray, the same one, but this time we're gonna use this overload of that method. Okay, so this one has an out variable, which basically tells us that it can, uh, give us, a lot of information back. Okay, now you must be asking, why didn't I use this one in the if? Because this one also returns bool, so it could have done two things with one stone. But the problem is, we wanted to give the user of our script all of these abilities to be able to decide the layers and stuff like that. So we allowed him to do fire a ray based on all these parameters, and then this time this ray is for us to get that information out. Okay, so we fire the same ray, the ray will be shooting, and this time we want to trigger this uh, overload. So for that, what we're going to do is say out, and now we need to have a variable we want to store all that information in. So let's store that information here. Hit information. Okay, no, raycast hit info. Okay. Now, we can say, okay, put all the information you gathered about the point you hit here. Now comes the interesting bit. Now we have first ensured that we did hit something, and then we uh, actually gathered some information about the point where we hit. So basically now we have the point where we want to attach the rope to. But there's a very interesting aspect, most likely to cause trouble for many people. The raycast hit info dot point. Okay, so this is the point where our ray hit the target or the wall or wherever our Spider-Man is shooting at. But if you notice, it's in world space. Okay, so what it means is if your wall moved or if you shot a web at a car that is moving, your web will attach to air or an empty point. The car would have moved, but you'd still be getting pulled to a point in the world space. We don't want that. So, how do we get around that problem? For that, what we are going to do is, first of all, we're going to say, okay, let me explain the solution I'm going to apply. The solution is we create an empty object, a transform, and we make it a child of that object which we hit after putting it at the exactly same point where we hit the ray. So in other words, now that transform is the child, and during this frame we knew where we hit that object. So we create an empty transform object on that exact point, and then we make that object a child of that other thing. So in other words, now if that object moves, our object, that point on the surface or of that object will move relative to that object, and it will kind of look exactly like we're attached to that skin point or whatever on the surface of that object. So what we're going to do is we're going to say new. No, in fact, let's create a variable for that. Variable anchor. Okay, anchor is a good point for that. Anchor point, because we are going to create kind of a hook at that place, is equal to new game object, and let's call it anchor. Okay, now with what we do is we make a global variable or field to store the point where we want to get you know, pulled towards, because the pulling, this is the firing method. Okay, getting pulled towards that is going to be a different method. Okay, so what we do is we say it doesn't need to be public, so we say anchor point transform anchor transform. Okay, so that anchor transform can be this object we created. So why not put it directly inside it instead of this variable? Okay, so now we have an anchor transform. A new game object is giving us an error for some reason. Change time field anchor form. Okay, no, we don't have to do that. We just do this. Okay, so store the transform of that object inside our anchor transform variable so we can access that anchor from outside this method for when we are pulling. So now we also need to remember that we might be detaching that rope at some point. So we say public detach, no, detach rope. Okay, so this will also be a public API method for our mechanic. Uh, Whenever they say detach rope, we're going to do that. But for detach rope, now we need to do is anchor transform. No, sorry. Destroy anchor transform no game object. Okay, now that object will be destroyed, and now we need another control variable called bool is the rope attached. Okay, so rope attached will be bool, and remember false is the default value, so we don't need to add it. So when we cast the ray inside the fire rope towards target method, and once we have created an anchor point, we need to move that anchor point exactly to the place where that object was hit. Okay, so we say anchor transform dot position is equal to hit info dot point, and now that our transform has been moved to that place where the object, the target object of the wall was hit. Now what we need to do is make sure that our anchor from that point onwards moves with the parent or that object whichever we hit. So what we say is the parent needs to be hit info dot transform. So in other words, whatever object we hit, that object's transform is our transform's parent. In other words, now the anchor is the child of that object. Next step is update the control variable. Attached is equal to true. Now we go there where we detach the rope and we say attached is equal to false. Okay, now okay, let me quickly see if I'm even recording since it's been so long. Okay, I hope I am. Now, next step is we need to make a method which will be run every frame, because getting pulled by a rope is not a one frame task. Okay, getting pulled by a rope needs to be done regularly and continuously, since you are getting pulled towards a target object, and the force needs to be applied continuously. So that gives us a reason to get our update method back. Okay, so we add update. What I did there was Control Shift M to trigger the Unity, mono behaviors, and also tools, extensions and updates. Make sure you have Visual Studio tools for Unity. Okay, I'm not sure if you need those for the latest version of Visual Studio, but this is 2015. Okay, anyways, back to the task at hand. So now we have an update method, and in that update method, we want to initiate the pulling mechanism. But for that, we need to ensure that whether our rope is attached or not, because if it's not attached, we don't have to do anything. But since it is attached, okay. Now, how do we pull ourselves towards that object? Okay, of course, we need to have reference to the rigid body. That gives us a reason to make a rigid body variable and call it rigid body reference. And now we have to have start. Control Shift M, start, edit. And now in the start method, let's store a rigid body reference is equal to get component. Oh no, not that. This one. Rigid body of the type and body, and there we go. Now we can pull ourselves towards that. Now let's get back to our update method. Let's say rigid body reference dot add force. Now what do we need? What we need is force, which basically is gonna be a way to tell the method both the direction and the magnitude. Okay, so vector3 can either be a direction, it can either be a position, or it can either be direction plus magnitude. Okay, I don't know if it's primary trigonometry or I don't know, but I'm going to teach you either way. So once we have it needs force. Okay, so of course, this is not a decision we can make, so we're gonna give them an option to public force magnitude. Okay, so this is gonna be a float force magnitude, and let's give it a default value so we don't, do nothing. Okay, and also, well, let's me do that step before you. Okay, so now we have a force magnitude. Now, what is the direction we should be firing our force towards? That direction needs to be towards the anchor, correct? So we're going to find our direction. This direction needs to be calculated every frame, because as I said, the object could be moving. Direction towards anchor. Okay, there is some spelling. Anchor. Now, direction towards, okay, here's another lesson. If you want to find a direction towards a point, what you need to do is, basically the formula is AB is equal to B minus A. Okay, so it's not even typing what I'm typing. Okay, so AB, in other words, a vector from A to B is equal to B minus A. Okay, so in other words, your origin goes later and your target goes first. Okay, so let's do that. Our origin, no, sorry, our target is anchor transform dot position, and we minus that with our game object, because since we are attached to that object, position. Now this has given us a vector which is both uh, position and a vector and magnitude. We want to remove the magnitude aspect from that vector. We only want a direction vector. Okay, we do not want the magnitude with it. Why? Because since if we use this direction towards anchor in our add force, it is coming with some kind of magnitude in itself. So it will add some kind of force and it will interfere with our magnitude. So it won't be 100F, it would be 102 or 101 or something. We don't want that. We want a pure direction vector. For that we do normalized. Okay, so now it's a normal vector. In other words, it's just a direction, not a magnitude. Okay, so we use that in our add force direction towards anchor, and the other one is force mode. Okay, this is an interesting thing. Why not give the ability to change that to our user? Okay, and user can be you yourself as well, since you want to be reusing this thing. Okay, so why not make this script configurable enough that you can, you don't have to edit the script again. Type of force, type of force, make it human readable, type of force. Okay, and then we say get it from the, okay, did I say mode? Yeah, so now this method will start adding force every frame as long as the rope is attached. Okay, this sounds like the our functionality for this mechanic has been achieved. Okay, or has it? Well, I think it has, but we need some kind of a way to test it, right? To test it, what we are going to do is make a temporary script to call our method. So testing mechanic. Okay, just temporary name. Attach that to the cuboid, and this script basically is going to be behaving in a like the uh, like our control script or whoever will be using that thing using our mechanic. So now we want to test it and see our Raycast pull mechanic is giving us all these options. Ray 100, let's make it 1000 objects of layer the rope can attach to, let's say everything for now. And do you want to attach to triggers, use global, or you can either say yes or no. Kind of force magnitude is 100 for now. Type of force, acceleration, impulse velocity. See, just by exposing those things, we have made our mechanic way more configurable. So this is our testing mechanic. All we want to do is go into start and simply say variable mechanic. Okay, this script is going to be is temporary, so don't get any bad habits from this one. Variable mechanic is equal to get compo. Okay, get no suggestions. Okay, thank you. Why not? Is this even correctly open? No, something is definitely wrong with this. Maybe it's still loading. What's that? Raycast? No, sorry. It's been a long time since I got my system. Visual Studio is kind of slightly buggy right now. Excuse the inconvenience, I suppose. See, it takes way too long than it should. Come on, you're embarrassing me. See? Okay, so simply say where or mechanic. Then we go to get element, full mechanic, store it, and then say mechanic dot row fire row towards target. Okay, so here we need to add some quick um, testing stuff. Okay, so we need the target game object, so we can fire a rope towards that. Okay, fire rope towards target. Okay, so if you see, it's asking for an origin or direction. We did add those things. So our origin is, of course, game object dot transform dot position, the current position we are at, and the direction is towards that game object. And remember, this is a direction, so we need to clean it. Okay, so direction is equal to the origin needs to be afterwards, so target.gameObject.transform.position minus gameObject.transform.position, and then normalize it. Normalized. Okay. Excuse me. Now we add that direction to it. Okay, so now we are ready to test this thing. Okay, we go back, we click the cuboid. It should be target, and the cuboid needs testing. Oh, did we make it public? No. Okay, see, for testing purposes, way better if we just dragged it. Okay, but in the real scenario, this testing script can be anything. It could be your first person, and you could give the direction towards where you were looking, or where you were wanted to fire your rope. Okay, so this is the other aspect of the usage. So that's why we're doing it in a hasty way, because this is not our domain right now. So cuboid testing target to fire towards that. Okay, so let's test it. What should ideally happen is our camera should go wonky. Okay, this is a good chance to teach you another thing. Click on the main camera and adjust your scene to where you want to view your thing. Main camera, click game object aligned with view. So now your camera is looking towards the what your scene view was looking towards. Okay, let's see what actually happened. Got it. I think there's an error. Missing component. There's no. Okay. Yes. Another important thing. Our script, since it says require type of rigid body, but it was already attached on that rigid body. It cannot create a rigid body unless you drag and drop on it. Okay. So the QBoy has no rigid body. So let's remove that script and see that in action. Now, if we attach it, oh, I actually it will add a rigid body. Okay, but it only triggers once you're attaching it. Okay, so let's say everything, force 100, range 1000. Okay, and save and play. Okay, did anything happen? Okay, now to test some of it, let's say, okay, force is too weak, I guess. Let's see what happens now. Okay, I think we need to bug fix some of it. Now in order to bug fix this, okay, I think I know the problem before even add a layer. There's a layer called target object that added it when I was testing it. Set the target object to target object and QBoy to, instead of everything, say nothing to uncheck everything, then say target object. Sorry, target object. Let's see if it works now. It did move a little bit though. Something is wrong. We do need to bug fix or something. Okay, first of all, it would be greatly helpful if we figured out where the ray was actually firing. Okay, so what we can do is say debug dot draw ray, and then in this place we say game object dot transform dot position, and the direction is the one we calculated towards the anchor. Okay, and one more thing before we do that, let's see if we're even hitting that object. QBoy, rope attached. Okay, is it not public? Okay, let's make it public so we can anchor transform can also be public since it's a kind of an API method, so we want them to know what's happening inside the script. Okay, I have a feeling it's not even, oh, it is hitting. Okay, there is an anchor on the target object. Okay, so it did hit it. So basically the rope is going towards that direction. Did we add the force correctly? Let's see. Rigid body dot add force direction towards the anchor. Oh yes, we forgot to add the magnitude. Remember, this direction is just a direction. It contains no magnitude. We forgot to add the magnitude. Okay, so force magnitude is multiplied by that vector. So a direction vector multiplied by a float number becomes direction plus magnitude. Okay, so let's go back and test it. This time I think 1,000 would be too much. Let's go back to 100, test. And there we go. It's, oh, that was a nice Spiderman move. Okay, so it is doing what we wanted it to do, but the force is, well, let's play with it a little bit. We're not doing it perfectly since this is not a use case scenario for our script. Okay, so this is kind of good enough. Now this can be upgraded to add more and more functionality towards it, to it. But our mechanic is kind of finished, but not as finished as we want it to be. So let's finish it. Let's add up some, touches. Header. Okay, these are called property attributes. In other words, the range attribute is taught in one of the tutorials, and a lot of people know about that. But header is a lesser known one. We say configuration. Okay, so these are the configuration variables. Okay, and then these are the header. Okay, now we're just polishing it up. So if someone else uses it, this script doesn't embarrass us or something. Runtime information. Okay, so save, and rope is attached. Okay, go back. See, this should clean it up a little bit. Okay, configuration, runtime information. So the user knows that these things will be updated once the actually starts working. Okay, so one last check. Detach rope should work. Yes, it should work. And once this is false, this will stop running, and our script will go back to silent mode. Okay, so I hope you enjoyed today's video, and I'm back. And also, I am thinking about starting a series about making a small, cute, tiny game from scratch. And my what I'm thinking is it should be a game about a small board where small AI creatures are living and surviving and stuff like that. So imagine if a snooker table was an ecosystem. So that's my basic idea. I would love your comments about what actually to do on that in that game. Okay, so I would love game suggestions, and I'm gonna make that game in front of you from scratch. Okay, starting from game design to the end. And please check out my Patreon. I recently started it, and thank you so much for your perseverance and waiting for my videos. Take care, guys. Thank you.